to study mathematics, concepts or definitions are most important. Okay, now today in today's discussion session, let me explain the concept first. Then I present examples. Okay. Today is about the limit of a function. Given a function, y is equal to f of x. In this function, x is independent variable. Independent means x can freely assume values. The value of y depends on the value of x. So we call y dependent variable. Okay, now the limit of the function. If when independent variable get closer and closer to some point A, dependent variable y is closer and closer to some number L. In this case, we say that L is the limit of the dependent variable y as x approaches A. Okay. Because y is equal to f of x, we also say that L is the limit of function f as x approaches the point A. Shorthand notation. In notation, we write L equal means is, okay. L is the limit of dependent variable y as x approaches A. This is the notation. Because y is equal to f of x, so we also write L is the limit of the function as x approaches A. Okay, this is the definition of a limit. Okay, about this definition, there are two very important conventions. Okay, two conventions. Keep these two conventions in mind. Okay. Number one is, okay, in the process of x approaching the point A, x is getting closer and closer to the point A. In this process, keep this in mind, x is not allowed to take the point A. Okay, x cannot in this process, in this approaching process, x is not allowed to take the point A. How about dependent variable y? It doesn't matter. However, y can take the number L. Okay, this is very important. Okay, this is convention number one. Convention number two is, if as x approaches A, y dependent variable approaches more than one number, more than one number. In this case, we say that, okay, y has low limit as x approaches a. That means that we require the limit is 1 and only 1. If dependent variable approaches more than one number, we say that the limit doesn't exist, low limit. Okay. In other words, okay, limit of y as x approaches a, or because y is f of x, or limit f of x as x approaches a, doesn't exist. Yeah. So when we solve a limit problem, always keep these two conventions in mind. Okay, this is very important. Okay, now after we understand the definition or the concept, let me show you two examples. The first example is from actually these two examples are from exam 1 last semester. Okay, now problem example 1. Example number 1. Okay. The graph of some function is given below. Okay, it's given below. Let me draw the graph. Y is f of x 0. Okay. Then here the graph. Solid point. Solid point means the point is part of the graph. Open dot means the point is not part of the graph. Let me see. There is a 7 here. There is a vertical asymptote. The graph. Let me draw a vertical line. Okay, then the graph. Yeah, the vertical red line is vertical asymptote. Go up to infinity. And then here, down to negative infinity. Okay, then open dot, this point is not part of the graph. Okay. Then there is a solid point, solid dot here. Okay. Hey, now let me okay. This point is number 3. And there is a corner here. This corner, the height is 2. Then this point is 5. Yeah, 5. How about this solid point, solid dot? This solid dot is 7. Okay, this is the graph of some function f. Now, questions. Okay. Questions. Okay. A. Find the limit as x approaches 1 from the left hand side. Yeah. This notation 1 minus means x approaches 1 from the left hand side. Function. Okay. What is this? Okay. What is this? Hey. Let me see. Okay. 1 here. Suppose 1 here. This point is 4. And this is 7, and this is 8. Okay, now to answer this question, x approaches 1 from the left hand side. So x on the left side of 1, say x is here. X is here. Now x is closer and closer to 1 from the left side. What is f of x? The height of the graph of a function is function value. So f of x is this height. Okay. Yeah. The height of the graph is function value. Yeah. This is f of x. Let me use a different color. Okay. Yeah. This height is f of x. Now, as x is closer and closer to 1, this green height is closer and closer to the height of this point. Do you agree? As x is getting closer and closer to 1, the green line is closer and closer to this red line. The height of the red line is 2. Therefore, the answer to this question, as x is closer and closer to 1 from the left side, function value is closer and closer to 2. 2 is the height of this point. So this is the answer to the first question. Now, second question. All right. B. Determine this limit as x is closer and closer to 1 from the right side. Yeah, the rotation from the right side is 1 plus. What number the function will approach? Okay, now let me pick x on the right side of the point 1. Say pick x here, x here. Right. X now is getting closer and closer to 1 from the right side. Okay, then what number f of x will approach? First, what is f of x? Function value at x. Function value is the height of the graph. So f of x is the height of this green line. Yeah, this is a f of x. F of x. Now, as x is closer and closer to 1, this height is closer and closer to the height of this red point. The height of this red point is 2. Therefore, the answer is 2. The answer is 2. Now, the third question, okay. C. Okay. What is the limit as x approaches 1? Now this time, x approaches 1 can from the left side, can from the right side. The both calls this limit both sided limit. Okay, both sided limit. Yeah. Then as x approaches 1, okay, either from the left, from the right, what number the function will approach. From this diagram, we can see that function value is the height of the graph. As x is closer and closer to 1, the height of the green vertical line will approach, get closer and closer to the red vertical line. The red vertical line, the height is 2. Therefore, the answer to this question is 2. Is 2. 2. Okay. So this is the first 3 questions from this example. Now, D. Okay, D. D. Find this limit. X approaches 4 minus. That means that x approaches 4 from the left side. Okay, what number the function will approach? Okay, what number the function will approach? Okay, now let me pick a point for x. Okay, x should be on the left side of 4. Okay, let me use a different color. Okay, say pick x here, x here, x here. Yeah, this x is on the left side of 4. Now x is getting closer and closer to 4. Okay, f of x, function value at x. Function value at x is the height of the graph at the point x. The height of the graph at the point x is this height. Is this height. This is the f of x. This blue vertical line is f of x, the length. Okay. Now, as x approaches 4, the blue vertical line is getting closer and closer to this red line, to this red line, right? Yeah. This blue, the length of this blue line is closer and closer to the length of this red line. The length of this red line is function value at 4. Okay, is the height of this solid point. The height of this solid point is 5. Therefore, this limit is 5. When x approaches 4 from the left side, function value closer and closer to 5. 5. This is D. E. How about right hand side limit at 4? X approaches 4 from the right side. From the right side, the rotation is 4 plus. Okay, what number the function will approach? Now let me pick a point for x on the right side of 4. Okay, say pick this point. Okay, this is x. Now x is getting closer and closer to 4 from the right side. Okay, f of x is the value of the function at point x. The value of the function at this point is the height of the graph at x. The height is, let me use this dashed line. Yeah, this height is f of x. Now, as x is closer and closer to 4, this dashed line, the height is closer and closer to the height of this open dot. Okay, the height of the open dot. Okay, yeah, the height of the open dot is this height, this green line. This green line, the height is free. Right? The height is free. So the answer is as x approaches 4 from the right side, function approaches number 3. Number 3 is the height of the open down. Right. This is a part E. A, B, C, D, E, F. Okay, F. How about the both sided limit? As x approaches 4, either from the left side or from the right side. Okay, this is a both sided limit. What number the function will approach? Recall that convention number 2. When we consider a limit, we require the limit is 1 and only 1. From part D, we saw that when x approaches 4 from the left, the function approaches 5. When x approaches 4 from the right side, the function approaches 3. So if when x approaches 4, the function has 2 different limits. Therefore, according to convention number 2, this both sided limit doesn't exist. Because we found as x approaches 4, 2 different limits. More than one limit, we say that the limit doesn't exist. This is a convention. Right. Okay, now this is a question F. Question G, let me erase. Question G. Question G. How about this limit? X approaches 7 from the left hand side. What number the function will approach? Okay, now approaches 7 from the left side. Let me pick upon, say pick x. Now approaches 7 from the left side. Okay. Function is the height of the graph at the point x. So function value at f of x is this height. Yeah, this is a f of x. Hey, now from this diagram, as x is closer and closer to 7, clearly this height is closer and closer to positive infinity. Do you agree? Positive infinity. So therefore, this limit is positive infinity. This is a G. H. How about this limit? X approaches 7 from the right side. From the right side. Okay. From the right side. Now, x approaches 7 from the right side. Let me pick a point. Okay, for x. Yeah, say this is an x. X approaches 7. Okay, from the right side. F of x is the height of the graph at x. Yeah, this height is f of x. F of x is height. Okay, now, as x is closer and closer to 7, this height, okay, first, positive, but beyond this point, when x is here, then the height is negative. As x is closer and closer to 7, this negative height becomes very, very large, but negative. So the limit is negative infinity. Yeah, this is the answer to H. I. Okay, I. How about the both sided limit? X approaches 7. Now this time, this is a both sided limit. X approaches 7 can be from the left, can be from the right. From part G, when we let X approach 7 from the left, function approaches positive infinity. When we let X approach 7 from the right, function approach negative infinity. Two different limits. Therefore, this both sided limit doesn't exist. DNG. Okay, DNG. Question J. How about this limit? X approaches A from the left side. What number the function will approach? Now let me pick a point on the left side of 8. Say pick X here. Okay. Now X approaches 8 from the left. Now let's see the height of the graph. Okay, the height of the graph is function value. X approaches A. This height is approaching the height of this open dot. Yeah, the height of this open dot. The height of this open dot is 5. So therefore, this limit is 5. Similarly, right-hand sided limit. X approaches A from the right side. Okay, from the right side. Okay. Okay, now from the right side. Yeah, pick a point. Say X here. Now X approaches A from the right side. F of X is this height. As X is closer and closer to the point A, this height is closer and closer to the height of this open dot. The height of this open dot is 5. Therefore, the limit is 5. Limit is 5. How about both sided limit? Okay. X approaches A can from the left, from the right. So this is a both sided limit. Okay. From this diagram, no matter how X approaches A, function value, the height of the graph always approaches the height of this open dot. The height of the open dot is 5. So the limit is 5. Limit is 5. The next question, the last question, question M. What is the function value at 8? What is the function value at 8? Now this time, you need to look for solid point. Yeah, function value. Okay, solid point is part of the graph. Open point, not part of the graph. Because solid point is here. Solid point here. Solid point is here. The height of graph is function value. The solid point is part of the graph. The height of this solid point is number 7. So therefore, function value at A is 7. This example is a problem from exam 1 in the last semester. 4/21. Now, today, let me show you a second example, also from exam 1, 4/2021. Example 2. Let me use black. Example number 2. Okay. The graph of function f is given. Okay, given below. Okay, is given below. Okay. When x is 0, function value is 1. This function is defined piece by piece. When x is not equal to 1, function value is 0. Let me plot the graph of this function. Because the function is defined piece by piece, we also plot the graph piece by piece. The first piece is here. When x is 0, function value is 1. Okay, so solid point here. This height is 1. 1. Second piece. When x is not equal to 0, function value is 0. So therefore, the graph is on the x-axis. On the x-axis. Put an open dot here to mean that the origin is not the part of the graph. The part of the graph is this solid point 1. Okay, so put open dot there. Okay. Hey, now questions. Okay. A. As x approaches 0, what number the function will approach? Okay, function value is height of the graph. Okay, x approaches 0. Remember convention 1. X getting closer and closer to 0, but x is not allowed to take 0. All right, when x actually this limit is equal to this. Okay, x approaches 0, but x not equal to 0. Okay, same. Okay, this is a convention 1. Okay, but when x is not equal to 0, the function value is 0 according to the definition. So this is a x approaches 0. 0. So the limit is 0. Limit is 0. From this diagram, we can see the limit is 0. Say pick upon x. X here. Yeah, x. Pick a point x. Now x is closer and closer to 0. Function is the height of the graph. The height of the graph is 0. So when x is getting closer and closer to 0, the height of the graph is getting closer and closer to the height of this open dot. The height of this open dot is 0. Therefore, the limit is 0. Limit is 0. Yeah. So from the diagram, we also see that the limit is 0. Part A. Now part B. Part B. Can you tell this limit? X approaches 0. Both side the limit. Okay. F of f. Okay. Yeah. Now this time, it is not easy to see the limit from the diagram. How to solve this problem? I suggest use a table. Okay. Use a table. Yeah. Yeah. Draw a table. Draw a table. Yeah. First column is independent variable. Second column, because this function is a composite function, combine f twice together. The second column, let me for f of x first. Now the third column, f of x. Okay. Okay. Now I let x approach 0. Okay. X approach 0. There are many ways x can approach 0. Okay. Let me arbitrarily pick points. Say x is 1 first. Okay. Yeah, 1 here. 1 here. Okay. Okay. 1 here. Okay. Now when x is 1, function value at 1, what is that? Go back to the definition of function. When x is non-zero, function value is 0. So f of 1 is 0. Okay. Then the third column, f1. Okay. F of 1, we know that it is 0. F of 1 is 0. Okay. Now f of 0. What is f of 0? Yeah, here. When x is 0, function value is 1. So this is 1. 1. Okay. So when x is 1, this guy is 1. Okay. Now, second point. X is closer and closer to 0. Now, closer and closer to 0. How about let me pick 0.5, right? 0.5 is closer to 0 than 1. Okay. Now, let me determine function value at 0.5. Okay. What is that? Okay. Okay. According to the definition of function f, when x is not equal to 0, function value is 0. So therefore, f of 0.5 is 0. 0. Okay. Now, let me compute this. Okay. X is 0.5. 0.5. This is a f. F of 0.5 is 0. So 0. 0. Yeah. F of 0 is 1. So 1 again. 1 again. Yeah. Okay. Right. Now the next point is x is getting closer and closer to 0. So the next point is how about let me pick 0.1. Okay, 0.1. Now evaluate function value at 0.1. F of 0.1. Okay. Go back to the definition of f. When x is not 0, function value is 0. So this is 0. 0. So, okay, now the third column, 0.1. This is a f 0. So this is 1. Okay. I continue to move x to 0. Okay. Now the next point, say let me pick 0.01, right? Very close to 0. Okay. Now function value at 0.01 is 0. Yeah, from the definition, okay, of f. Okay. Then f 0.01. Okay. Okay. From the second column, function value at 0.01 is 0. So this is a f of 0. So again, 1. 1. So okay. One more point. 0.001. Okay. Function value at 0.001 is 0. F 0.001 is f of 0 is 1. So therefore, from this table, we see that as x approaches 0, in this table, I pick x on the right side of 0, right? 1 here, 0.5 here on the right side, then 0.1. 0.01. So as x approaches 0 from the right side, okay, f of x, yeah, this guy approaches 1. Approaches 1. Okay. Yeah, this table is about x approaches 0 from the right side. From the left side, similarly, okay, when x approaches 0 from the left side, f of x also approaches 1. Make a second table. So therefore, the both sided limit. So conclusion, as x approaches 0, this function, the limit is 1. The limit is 1. So to solve part B, we need to make table because from the diagram of the graph of the function, we cannot see the limit easily. So this is a part B. Okay. Now part C. X approaches 0. Okay. F of 4 plus x will approach to what number? Okay. Let me erase. Okay. Let me erase. This time to answer this question, again, it is better to use a table. Okay. Okay, now let me make a table. First column, independent variable. Because function, there is a 4 plus x. Okay, now second column for 4 plus x. Now the last column is function value at 4 plus x. Okay. Now again, x approaches 0. Okay, this is a both sided limit. How about approaches 0? Now this time, let me pick points from the left side of 0. So -1 first. 4 plus -1 is number 3. So the last column is f 4 plus -1. Function value at 3. Okay. Now function value at 3. From the definition of the function, when x is non-zero, function value is 0. So this is 0. 0. Now Second point. Say how about 0.01? 0.01 is close to 0. Okay. 4 plus x, 4 minus 0.01, 3.9. Okay. Now function value at 3.9. It is 0. Let x even closer to 0. Yeah. So this is a 3.99. Then this is a 3.99. It is 0. According to the definition of function f, whenever x is non-zero, function value is 0. Okay, and so on. So from this table, we can see that when x approaches 0, from the left side, right? This guy, the last column, approaches 0. Approaches 0. Similarly, when you let x approach 0 from the right side, you also see the limit is 0. So therefore, conclusion is this limit is 0. This limit is 0. When x approaches 0, the limit is 0. Yeah, this is two examples today.